Motorgrader performs a variety of maintenance tasks: grading shoulders, cleaning ditches, mixing asphalt, and the list goes on. The critical factor in all of these operations is blade position. You can choose from an infinite number of blade angles and heights to meet the demands of any grader operation. Here are a few possible blade settings and their uses on some common maintenance activities. There are 5 blade movements: blade lift, circle rotation, blade pitch, blade side shift, and circle side shift. All grader operations require a combination of some or all of these basic movements. The hydraulic controls in the cab of the grader direct each of these movements, but the controls may vary from one model of motor grader to the next, so we'll concentrate on the movements, not the controls. The first movement is blade lift. You can raise and lower the entire moldboard or just one end at a time. For example, if you want to level an area, set both ends of the blade at the same height. If you want the surface to have a crown or slope, set one end of the blade slightly higher than the other end. There are 2 basic operating heights: the loose blade, when you lower the blade until it barely touches the surface, and the tight blade, when you put enough downward pressure on the blade to dig into the surface. A loose blade works best when the job calls for spreading or mixing loose material without damaging the pavement underneath. A tight blade is used when you need to reshape the surface by cutting into it. However, most jobs require a combination of loose and tight blading. Generally, you set the toe or leading end of the blade slightly higher than the heel or trailing end. This works well when you're cutting and windrowing material. The second blade movement is circle rotation. The blade is attached to a circular mechanism mounted on the grader's frame. By rotating the circle clockwise or counterclockwise, you can achieve any blade angle through a range of 360 degrees. When a blade is straight across the frame, it's at the 0 degree or spreading angle. All other blade angles are measured from this position. As the name suggests, the spreading angle is used for spreading material. The blade pushes the material forward with a dozing action. The material spreads to both ends of the blade, leaving little or no windrow on either side. As you rotate the circle, you change the blade angle. Most jobs require a blade angle of somewhere between 15 and 45 degrees. When you increase the blade angle, you increase its ability to windrow rather than spread material. The general rule is to use a sharper blade angle to make a larger windrow. The blade angle also affects the placement of the windrow. In most cases, you want to set the blade angle to place the windrow either outside or inside the rear wheels. What you don't want is to have the rear wheels riding on the windrow. That reduces traction, and the up and down movement of the grader will make your cuts uneven. A change in blade angle often results in a change in the blade height. As you rotate the circle, one end of the blade goes down as the other end rises. So after you change the blade angle, you may also have to adjust the blade height to get the position for the job you need. The third movement is blade pitch. Blade pitch is the vertical angle of the moldboard. You can pitch the blade forward, backward, or leave it in the upright position. A forward pitch gives the blade a dragging action, and the backward pitch gives the blade a cutting action. This operator has the blade pitched slightly forward. By applying only slight downward pressure on the blade, the surface can be dragged and smoothed without cutting into it. The forward pitch rolls the material off the moldboard. This process helps mix the material. The forward pitch also provides compaction. It squeezes the material together for better mixing. So, for dragging or smoothing the surface, or for mixing and compacting the material, use a forward pitch. However, for cutting or reshaping the surface, use the backward pitch. In this position, the cutting edge of the blade is up front. By applying downward pressure on the blade, you can dig into the surface instead of just dragging it. but the material will pile up in front of the moldboard and won't roll off very easily. You lose the mixing and compacting action you get with the forward pitch. So for most operations, pitch the blade upright or slightly forward. That gives you both the mixing and cutting action most jobs call for. The fourth blade movement is blade side shift. Blade side shift extends the reach of the grader. You can shift the blade to the left or right, a handy feature when the work is hard to get to. This blade movement lets you keep the grader on a stable, level surface. You can extend the blade to reach the work area. You can also use blade side shift as a safety device for working on slopes by extending the blade to the downhill side of the grader. The fifth and final movement is circle side shift. Circle side shift accomplishes the same thing as blade side shift. It extends the reach of the grader. The differences are that in blade side shift, only the blade moves, but in circle side shift, you can move the entire circle from one side of the grader to the other. That not only extends the reach of the grader, it also makes it easier to position the blades for certain type of use. To reach the back slope of the ditch, the operator has shifted the circle to the right side of the grader. After that, he's able to lift or lower the blade and change the blade angle and pitch while he's in the ditch. Without circle side shift, there's no way you can position the blade in such tight quarters. Let's quickly review the 5 movements. Blade lift, circle rotation, blade pitch, blade side shift, and circle side shift. All Motorgrader operations involve a combination of these 5 basic movements, but it's impossible to assign a specific blade setting for any particular job. What we've seen here are guidelines. You'll have to experiment with different blade positions on the job to see which setting works best. Now let's look at maneuvering the grader. Before you leave the yard, you have to position the blade for travel. Lift the moldboard and rotate the circle until the heel of the blade is in front of the left tandem tire. The toe of the blade tucks in behind the right front tire. Not too close though. You don't want the blade to hit the tire when you turn. Try to keep the moldboard within the width of the grader. However, if the moldboard is too long, extend it out to the right side so it won't interfere with traffic. For the most part, driving the grader on the road is about the same as driving any piece of equipment, and the same rules apply. For example, if your grader has rollover protection, wear your seatbelt. Always travel at a speed that's consistent with road, the traffic, and the weather conditions. Upshift and downshift the transmission 1 gear at a time and stay in gear. Never coast in neutral. Always slow down well in advance of intersections and turns. The grader is a heavy machine, and once it gets rolling, it needs time and distance to slow down and stop. Okay, nothing new there. But graders have a couple of moves that you might not be familiar with. The first is front wheel lean. There's a control in the cab that lets you lean the front wheels to the right or to the left. You can use front wheel lean to help you get the grader through sharp turns. Watch how the operator takes this turn using normal steering. To make the turn, he has to cross into the opposite traffic lane, and that could be dangerous. Now, watch him make the same turn using front wheel lean. As he enters the turn, he leans his front wheels into the direction of the turn, and at the same time he turns the steering wheel. As a result, he's able to stay in his lane and make the turn safely. And one more point. After you go through a turn using wheel lean, return the wheels to their normal vertical position. If you don't, the grader will drift into the direction the wheels are leaned. You could end up driving off the road and into a ditch. Articulation or frame steering provides additional help in turning. By articulating the frame, you can cut down on the amount of room you need to turn. The thing to remember here is, always check the position of the blade before you articulate the grader. If the blade comes into contact with the rear wheels, you'll be replacing a lot of tires. You can use wheel lean and frame steering to maneuver the grader on the job as well as on the road. For example, when you are windrowing the material, the weight of the material pushing against the toe of the blade pulls the grader in that direction. You can counteract that pulling force by leaning the front wheels in the direction you are moving the material. That helps you keep the grader going in a straight line. And when you are pulling a ditch or working on a slope, use frame steering. It lets you keep the rear wheels on stable ground while the front wheels ride on less stable or uneven ground. That reduces the up and down movement of the blade caused by variations of the surface, and you get a better cut. As I've said before, exactly how you position the grader and set the blade is determined by many factors, but for most types of work, the normal operating position of the grader should be like this. The frame of the machine is in a nearly straight position, so the front and back wheels almost follow the same path. The front wheels lean 10 to 15 degrees in the direction you are moving the material, with the blade pitched slightly forward and angled between 15 and 45 degrees to cut and windrow the material.